So the last few days we have been looking at the heart. And so as one final check on yourself, you may want to take a look at these two questions and see if you can trace out the flow of blood and identify the anatomical structures involved. And then just make sure you understand what's going on with this diagram here, the ECG, and why it has this particular pattern of peaks that it has. But remember, the heart was just the first component of the circulatory system. There was the heart, the blood vessels, and the blood. So now we're ready to turn our attention to the second component, which is the blood vessels. Now, I want to remind you that the heart has to pump blood to all the cells in the body. All the cells are going to need oxygen, they're going to need nutrients, they're going to have their waste removed. So the blood vessels need to reach every single cell in the body. And so this diagram, it kind of shows that in sort of a schematic way, but it's not all that neat and tidy. Here's another picture that shows in a little bit more detail what's happening. So you can see the blood vessels leaving the heart and going out to the arms, branches down here to the legs, branches down to the head. And yet, I look at that, and is every cell in the body getting blood based on this diagram here? For example, the pectoral muscle here, I don't really see a blood vessel going there. So is this the best picture in the world? Well, no. So why are we using it? Well, think about this like a freeway map. This diagram is showing the major blood vessels in the body. It's showing the Highway 62s, the Highway 100s, the 494s, all the major ones. But there's a lot of detail missing from this diagram. There are smaller blood vessels, the Tracy Avenues, the 50th Streets, the France Avenues, and then there are even tinier blood vessels that branch off of those. Think of those like those little tiny streets in Edina that many of you probably live on that no one's ever heard of. So for example, right by the high school, there's this little cul-de-sac turn. I think it's called Rosemary Way. Who's heard of Rosemary Way? No one, unless you live there. So the blood vessels are the same way. You got your major freeways, you got smaller branches off of there, and then you've got your tiny little blood vessels that make their way to every single cell in the body. So to show this, to prove this, I'm going to show you some pretty cool pictures. I'm going to click the screen, and I will show you a picture of an animal. This animal was after it had been after it was deceased. I'm not sure how it was killed or died. It probably was killed. They injected this liquidy plastic material into the blood vessels, and it hardened in the shape of the blood vessels. And then they essentially threw the carcass in a vat of acid and some other chemicals that stripped away all the protein, all the fat, and everything, and pretty much just left behind that plasticky material that was injected in the blood vessels. So what you're about to see is the blood vessels of an animal and nothing else. And I want you to see if you can identify this animal based only on the pattern of blood vessels inside of it. Are you ready? Did you say chicken? You're wrong. It's a rooster. A chicken is a female. Sexist pigs. This is a rooster. And if you look at this, you can think, oh my gosh, yeah, there's blood vessels going absolutely everywhere. You can totally make out all the detail of that creature. Here's one where they did the same thing with humans, presumably with permission. This is from what's called the Body Worlds exhibit, which has been at the Science Museum in Minnesota. And then here's a really cool one just showing the head, and you can just see all the intricate detail. Like, look at all these blood vessels, and you can see this is a major one. That's the carotid artery in your neck where you can feel your pulse. That's definitely one of the major freeways. And then you can see some smaller roads and then these teeny tiny things. But you get a much better image. Truly, all the cells in the body have access to blood vessels. So I want you to keep that in mind. We're going to revisit that freeway map later on and learn the names of those major vessels as we go through. But keep these pictures in your mind as we do that moving forward. So today's goal, though, really is just to look at the types of blood vessels. and get to know them. And I'm guessing you've heard of these. There's capillaries, there's arteries, and there's veins. So capillaries are first. These are the site of exchange between the blood and the body's cells. These are the rosemary lanes of the circulatory system. They're teeny, they're tiny. Note that blood cells are traveling in single file through these things. That's how narrow they are. They're microscopic. So if you get a cut, blood will come out. If you get a paper cut on your finger, and you might think, well, how am I bleeding? I don't see like severed blood vessels or anything. Well, there are severed blood vessels. They're just microscopic severed blood vessels. These little tiny capillaries have been severed, and that's why blood is leaking out of you. So our whole body is lined with these capillaries. They're everywhere. You've seen capillaries before. These are what surround the alveoli in the respiratory system. So when you take a deep breath, the oxygen goes down into your lungs, inflates these little air sacs, and then the oxygen diffuses into the capillaries surrounding them. And again, because they're so tiny, that helps with the exchange of materials across them. You'll notice that the walls of these are made of cells, and those cells are very flat, and they're only one cell thick. And you may recall we learned about this type of epithelial tissue before. In Unit 1, we looked at them. One layer, flat cells. You remember what that is? Simple squamous, yeah, simple squamous. So these are simple squamous, again, very flat, because that facilitates the movement of oxygen and carbon dioxide across the wall of these capillaries. And then again, again, you bleed because these capillaries get severed. And a bruise, by the way, is the pooling of blood as a result of capillaries that have been damaged beneath the skin. So if you get, punched or something, then you may not break the skin, but you've damaged capillaries, and that pooling of blood appears as a bruise. That's what a bruise is. That's kind of fun. Okay. Well, the capillaries are kind of in the middle of the other two types of blood vessels. So the next major type is an artery. Arteries carry blood. You may remember this from bio last year. Arteries go away from the heart, and think artery away, AA. They branch into smaller blood vessels called arterioles, which you can see here. And so arterioles are smaller arteries. So you can think of arterioles like your 50th Streets, your France Avenues, your Tracy's, your Vernons, those kind of bigger roads, but not major freeways. And then the arterioles branch further into those smaller capillaries. The blood is transported by the force of the heartbeat. So remember what we said about the heart. The heart beats, boom, and it just kind of launches that blood through. And so every time your heart beats, if you look at my picture on the screen at the bottom, the arteries kind of get this like boom, 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 and they almost pulse with every single heartbeat. And sometimes you can feel that. And you know what we call that? Our pulse. So if you feel in your neck, you should be able to feel the pulse of your carotid artery, that blood vessel going to the neck. And what's happening is every heartbeat, the blood vessels kind of going ba-boom, ba-boom, ba-boom. And that's why you can count your heart rate by counting the pulses, because every pulse is the heart kind of pushing the blood through. And so, the blood is basically transported by the force of the heartbeat, and that force is considerable, and it's enough to get the blood to your head, to your arms, to your feet, everywhere. This raises an issue, though, because if the blood is surging through there at a rapid rate, if you damage that artery, that's going to be bad news. Blood is going to be very rapidly leaving your body. And so as a result, these tend to be located deep in your body. In fact, all your arteries are pulsing that way, but you can't feel it for the most part because they're buried deep inside your body, within and between muscles and things like that. There's only a few places where the blood vessels get close enough to your skin that you can actually feel those arteries. Your carotid artery is one place. Your radial pulse is another. The radial pulse is in line with the radius, which remember is the bone in line with your thumb. So if you put your two fingers kind of where your wristwatch would be. And in line with your thumb, you should feel a pulse there. There's a couple other places. There's an area, I think your armpits, there's a place you can feel it. There's one in the groin area. There's places where these arteries get close enough that you can feel that pulse. But for the most part, they're deep. And that's basically because it's safer that way. If you were to cut an artery, that blood is going to be and just squirting out very quickly, which obviously is not good. Finally, they contain thick walls to withstand the force of the blood. So if you look at this muscular wall here, it's very thick because as the blood is going through, ba-boom, ba-boom, that thick wall helps them withstand the force of that. So I think I'm going to pause and then we'll start another screencast to continue with veins. But before that, finally, a joke. What's a pirate's favorite type of blood vessel? Veins. Everyone always says arteries, but they actually like veins. Okay, see you in a moment.